All right, so I'm grading the Newton's second law labs here, and some people are struggling a little bit with how to make the free body diagrams. So rather than write them out on everybody's lab or on a lot of the labs, I figured I'd just make a quick video. So here's the deal. Um, so what you were asked to do is find a trial in your experiment where your predicted acceleration was bigger than your experimental acceleration. Ideally, that was all of them, right? Because your predicted acceleration didn't include friction. All right, so let's suppose that I looked at, let's just do part one, trial one. All right, so the idea there was you had a system that looked like this. You had your cart, and the mass of the cart was 1.98 kilograms. And then it was attached to a little hanging mass that was 0.02 kilograms. Okay, so if you had figured it out, your predicted acceleration there should have been 0.163 meters per second squared. All right, so let's suppose you went through and you did the lab, and suppose you calculated your experimental acceleration, and maybe you got, I don't know, say 0.09 meters per second squared, right? And again, it's reasonable that that number could be smaller because it's not affected by friction, right? So here's the deal. So if you look at the forces acting on your system, there are going to be two forces acting on it, right? You're going to have gravity pulling this thing down, which is just going to be our hanging mass times 9.8. So it's going to be negative. Well, we made that positive, didn't we? So let me erase that. All right, so, sorry. Okay, so this force should be 0.196 newtons, right? Okay, but based on this experimental acceleration, we can find our net force, right? The net force, and notice everything I'm looking at here is for the system, right? So my net force should be the mass of the system times the acceleration. So the mass of this system in this example is 2 kilograms. The experimental acceleration is 0.09 meters a second squared. And so our net force, if you multiply this, is 0.18 newtons, right? Okay, but so then the question is, well, wait a minute. If I've got 0.196 newtons pulling it forward, then why is my net force only 0.18 newtons? Aha, there must be some friction. So let's figure out how much friction there is. So the idea is we know that our net force is the force of gravity plus the force of friction. I know the net force is 0.18 newtons because I just figured that out. That's got to equal my force of gravity, 0.196 newtons, plus the force of friction. And subtract and solve it, and you find that your force of friction is negative 0.016 newtons. Aha, now I know my friction. Okay, so, and then I guess technically speaking, we should probably put in our, the force of gravity here would be 1.98 times 9.8, and our normal force would be 1.98 times 9.8. So you should put those in. Okay, so there's the free body diagram of the system. So notice, you got to start with the system, right? That's how we solved all of these problems when we were doing this chapter. Okay, so now let's take a look at, let's do the cart first. Let's look at the cart just by itself. Okay, so if you look at the cart by itself, then here's what's going on. So here's the cart, right? All right, so here's the cart. Oh, it's floating for some reason. It's still got a mass of 1.98 kilograms. All right, we know friction is resisting its forward motion for the force of negative 0.016 newtons. We just figured that out. We know the acceleration of the cart is 0.09 meters a second squared, and we know there's something pulling it forwards. That something is tension force, but we don't know how much tension there is. But because I know the acceleration, I can find my net force. It's going to be mass times acceleration. So my mass is 1.98 kilograms. The acceleration is 0.09 meters a second squared. Multiply this out, and your net force ends up being 0.1062 newtons. Okay, so now I can find my tension, right? Because I know that my net force should be the force of tension plus the force of friction. So my net force is 0.1062. Force of tension is what I don't know. My friction is negative 0.016. And so the force of tension, if you solve this, if you add the 0.016, it gives you a tension force of 0.122. Why does that seem wrong to me? Sorry about that. It's 0.1222 newtons. Okay, so there's my tension force, 0.1222 newtons. And then again, technically you should put in your gravity and your normal force. All right, so there's the free body diagram for that. And then finally, we got to look at the hanging mass. All right, so again, the hanging mass is going to be affected by tension. So hopefully we'll get the same tension value. All right, so here's my hanging mass. The hanging mass was 0.02 kilograms. Gravity is pulling it down with a force of 0.196 newtons, and there's a tension force that we need to find. All right, well, we know the acceleration, 0.09 meters a second squared, so net force is mass times acceleration, so 0.02 kilograms times 0.09 meters a second squared gives you a net force of 0.0018 newtons. So now I can find my tension. Net force should be gravity plus tension. So 0.0018 equals 0.196 plus tension. Subtract the 0.196 and you get a tension force that's negative 0.1222. Okay? And notice it makes sense that this tension is negative because we set it up so that positive was, sort of forward and negative was working against the motion. Okay? So that is how you should have solved those, or how you should have made those free body diagrams. Okay?